This question is path with maximum probability. So given the undirect graph, and you are going to given the edges and also the probability between the edges. And this is your start, this will be the end, and then this will be total indices. So what you need to do is you want to return the maximum probability from start to the end. So I'm going to explain the idea pretty fast. So yeah, for in this question, so I'm going to jump to two examples. Maybe I can screenshot this together. Alright, so in this example, example 1, the answer will be 0.25. How do I get this? So let's see. From 0 to 2, I do have by default 0.2 because I can get the weight, the success probability from here, right? So what you need to do first, based on the edges and then the success prob, you can create a graph. So you will say 0 to 1 has the age of 0.5. So it will be comma, so and then this will be 1 to 2, and then comma, and age will be 0.5, and this will be 0 to 2, comma, will be aged for 0.2. Okay, so the idea is that from node 0 to node 2, I have the weight of 2.5. Okay, for node, another color. So for node, maybe another one. So for node 0 to node 1, I do have a higher probability, 0.5, but it's not reaching to the end, right? But when you do another iteration from node 1 to node 2 in this pattern, so this will be 0.5 times 0.5, right? So it will become 0.25. So, and then 0.25 will be greater than 0.2, which is going to be greater than this path. That being said, you have higher probability to reach from 0 to 2. So what we always want to do is we want to compare with whatever the current probability you have, and this will be a new probability when you traverse a neighbor. In this example 2 is pretty straightforward. 0 to 1, 1 to 2, they are the same, but 0 to 2, they make change to 0.3 probability. And whatever they're trying to guess, so we already know this pattern is 0.25. However, 0.25 is actually less than 0.3, so we're not going to make any change for the result, because between 0 and 2, no, like I already know the highest probability is 0.3. Why am I picking 0.25? So I'm going to write out the solution, and then this is the graph solution. I'm going to write out the solution and then explain what I'm typing. So first thing first, I need to build out the graph. So my graph is going to using a hash map. So I'm map, and then key will be the integer that will represent the current node, and then the value will be the list of the double. And I'm just assigned to graph. So assign the value to a graph. So my list of double in array. So this is double array. So I will contain the index, the neighbor index, and also the probability. So for in I equals 0, I less than ages, dot length I plus plus, and I will say a equal to ages at I is 0, and then b will become ages at I at 1, and then I will do the prob for probs as well. So double. So what you should do is you want to actually build out the graph for the node, right? So doing a compute if absent for a, if the node A is not in the map, I'm going to initialize, and then I'm going to add the parent. I mean, sorry, the double double array, which is going to be a neighbor. So new double, and then b at pop. So from node A to node B, I have this probability, but that is also the same from node B to node A, right? Because it's undirect. So copy paste and then changing this to value. So I will build the graph for A to B and also B to A. So once I have it, I want to also make sure what is my current probability for each node. So for each node, I will have a double. I will say props add new double and then assign the size to the n. Right? You have a node, then it's going to be each node has its own probability, and the probability for starting node is actually 100%, right? It's actually 1. Like you won't, like you will start from your node 0. Like this is going to be that 100% you're going to start from it. So you will have like probability for star node will be 1D. So you will always having success success part for the starting node, and then I will keep the remaining for 0 because we are not traversing. And once we are traversed, we always want to make sure the highest probability will have the treatment first, right? So I'm going to have a priority queue. I'm going to say double array, and I'm going to say pq equal to new priority queue. And I do need the order, so I'm going to order based on, so A to B, I'm comparing two node, like two double array. So I already mentioned that the index 0 that represent a neighbor, index 1 will represent probability. So whoever has a highest probability let you go first, right? Because we always want to find out what is the maximum, right? So compare, so double, and I will say B1 and then A1. You can say B1 minus A1, so it doesn't matter. Alright, so now I will just add the default starting node into the PQ. So the PQ for index 0, that will represent the starting index. And the probability there is actually for the starting node is 1D, right? We already know. So while the PQ is not empty, I will just keep traversing. Okay. If you finish the traversal and somehow you are not finding your ending node, so for example this one, you're not finding your ending node, so you'll return 0. So that is also equal to 0D. Okay. So the first thing in the while loop I'm going to poll. So I'm going to say no equal to pq.poll, and then I will say current index, probably that will be best. Cast the value to int for node at 0, and then double that will represent the current prop, so node at 1. So this is two value that I would get from the node, which is how I assign over here. And if the current index is equal to the end node, I will return the probability that we just have. This will keep updating, and whenever it get pushed, it will definitely get updating here as well. But since we're adding the value into the PQ, we can just return the current probability. And we want to make sure the probability we traverse is always a valid one. Like we're not traversing when the probability is less than, right? So if the current probability is less than the probs at current index, so imagine this. This is 0.1 for current probability for this index, and I already have a highest probability for another path. Just imagine that, like another path from here to here, right? I have 0.3. I don't need like 0 to 1, 1 to 2 probability, right? So 0.5 times 0.5 is 0.25. If this is 0.25 and I already have 0.3 right here, I don't need to traverse, so I will just say continue. Alright, now after all this, I can traverse my neighbor. So my neighbor will be double. So I will do the graph, and then I will do the get or default based on the current index, right? If the current index is not in the graph, I will just have the empty list. I will have an empty list, and this for loop will immediately break. So either you have a double either you have a list of double array, or you have empty list. And if you do have an empty list, then you're not traversing the for loop. Alright, anyway, so I would do the same thing for this. So in next index, do a cast for neighbor at 0. And also I want to make sure my next prob is neighbor at 1. So for the next probability, I want to also times my current probability, so I will get a new probability, right? So new prob will become the current prob times new probability. So next probability will only use in here because I already have a new probability between two index, right? Technically between two index, I mean like node. So for between 0 to 1 is definitely the probability that we have, and then 1 to 2 is the neighbor, right? So it will have 0.5 right over here. So 0.5 times 0.5, that will become 0.25. So I do have the new prob, so I want to do a comparison. If the new prob is greater than whatever I have in my next index, in my record. So this is my record. I keep in track of record. If this new part is greater than the record, I will update my records to the new part. And then I will just add the current path, the current record into the queue, because since you have a highest probability, you might end up getting the highest maximum probability in the path. So I would say pq.offer new double, and then it will become the next index, and then next new prob, right? We don't pass in the next prob because once you need to keep having the updating probability for the path, so you always pushing the new prob, not the next prob, into the PQ. So that being said, is pretty solid. Yeah, so this will be a solution. So for the time and space, yeah, for traversing the node and then traversing the while loop, so the graph for the time and space are considered the same. Is all of v plus e times log v. So I'll pen over here. So it will be all of v plus e. V represent the vertices, e represent edges, and log v, this for time, So why do we have log v? Like, since we are sorting that, this is how we get a log v, right? And this will be a number of the integer that you will need to sort. Okay, anyway, and then space will v plus e because we need to store this, right? So this is a wonderful solution, and it's, I would say it's pretty easy to understand. There's another one, and I'm just copy paste my solution. I'll explain. So it's a little bit shorter, but that doesn't mean it's easy to understand. So let me dive into the solution. So you're still building a graph. In this time, you're gonna have an inner rate, and you're traversing the edges between A and B. Okay, you build a graph A and B for the current index. Okay. So A and B with the current index I, B and A current index with I. So you will do the traversal. Okay. So I will still have the record to keep on track with my pop, and I started my current starting node as 1D, which is that you always have the 100% probability to visit a starting node, and then you have a queue. So this time you're using a queue instead of PQ. So I add a starting node into the queue, so it's integer, right? Integer that will represent the node index. So I will traverse until it's not empty. If this is empty, then I'll just return whatever the probability record that we have. Okay, and then if not, then I will poll, and this will represent whatever the current index that we are trying to traverse. So we traverse the current index or the empty list that will represent a neighbor. Okay, and then I will pull the data. So this will becomes what? So this will be a neighbor at index 0, and then index 1 that will represent the current indices in the edges. Okay, just think about this, and then what you need to do is you want to time whatever the current probability times the probability for the next neighbor index, something like this. So you will get a new prop. So this will be a new prop. If new prop is greater than whatever you have in the record, so prop for the neighbor, then you do the update, then you push into the queue. So the only confusion will be this: like how are you going to how are you going to convince this is going to be a new prop? So you need to actually understand how you build a graph. So if not, then you won't be able to understand this. I was having difficulty understanding this as well. Alright, so for the time and space, they are the same. Time will be all of v plus e log v, and in space will be all of v plus e. This is the same across to all graph algorithm. And yeah, other than that, this is not a big issue. And I'll see you later. Bye.